physics students. I hope you're all safe and sound, doing your sheltering in place, um, surviving this strange thing. I hope you got to go to the assemblies that they had for the classes. Yesterday, I was sitting in with the senior assembly, and hopefully, we'll get some things straightened around with you guys for graduation and what. Okay, so today we're going to start chapter 6 on momentum and collisions. So you might want to get a notebook out or someplace to get some notes down so that we can learn about momentum and collisions. And hopefully you've finished the chapter 6 introduction. All right, so let's get started. First, what is momentum? Momentum is the quantity of motion that an object has. Okay, how much motion an object contains. A little bit strange. Momentum is equal to the product of the object's mass times its velocity. Okay, the object, mass times velocity. Okay, important thing here, pet peeve. This is not the letter P. I repeat, this is not the letter P. Please don't call it letter P. It is, in fact, the Greek letter rho. Okay, so momentum is rho, not P. So please don't say P. The unit for momentum, since it's mass, kilograms, times velocity, meters per second, it's the kilogram meter per second. And as usual, it has a unit named for a very famous physics person. That's right, it's known as the spheres. No, I'm not kidding. The spheres, signified by a big capital S. Okay, the spheres. Okay, so that's momentum, an object's mass times its velocity. So how do we change momentum? Impulse is what causes a change in an object's momentum, signified by the letter J. So an impulse is a change in momentum. Okay, so impulse equals delta rho, change in momentum. Now, remember that momentum was mass times velocity. So if I'm going to change an object's momentum, what am I going to change? Am I going to change the mass or am I going to change the velocity? Most times, in fact, all the time, it's going to be mass times a change in velocity. Okay, that's how we get a change in momentum. Mass times a change in velocity. And wait, change in velocity is what? Oh, yes, acceleration. So recall from last chapter, F equals ma. And acceleration is equal to velocity divided by time. So if we take those things and put them together, right? Let's change color here just briefly. So we've got F equals ma, and acceleration is a change in velocity divided by time. So F equals m delta v over t. We can multiply both sides by t, and we get ft equals m delta v. So another way to talk about impulse, okay, another way to talk about the impulse of an object, besides mass times change in velocity, is a force acting over a given time interval. Can also be or create an impulse or a change in momentum. So all of that can be written together. Now, let's take a view of how this works graphically. Right? We just talked about force and time. So let's take a look at how we can do a graph of that. Suppose we had a force time graph. There's a couple different ways you can cause a change in momentum or an impulse. You can have a small force acting over a long period of time. Okay, so this area of this rectangle, the amount of force multiplied, the amount of force multiplied by the amount of time will give you an impulse. You could also create that same impulse having a very large force acting over a short period of time. Okay? That will cause a change in momentum or an impulse. So either way, you get the same amount of impulse or change in momentum, whether it's a small force acting over a long time or a large force acting over a short time. Think of it this way. Your car going down the road at 30 miles an hour. It has momentum. There's two ways you could change your car's momentum. You could apply the brakes nice and slowly for a long period of time, causing it to go from some amount of momentum down to zero momentum. Or you could run into a non-moving object, which would cause your car to change momentum very quickly. So a much larger force in that short period of time. Which would be better for the driver? I think we all know the answer. Okay, time for a sample problem. A pitcher throws a 0.2 kilogram baseball with a velocity of 60 meters per second. The batter swings and hits the ball back toward the pitcher at a velocity of 40 meters per second. What is the change in momentum, the impulse, imparted on the ball? All right. So let's start with, as usual, our drawing. So we've got a baseball originally thrown by the pitcher with a velocity of 60 meters per second. We've got that same baseball hit by the batter with a velocity of 40 meters per second. All right, let's talk about momentum. So the original momentum of baseball, mv, right, 0.2 times 60, or 12 spheres of momentum. The hit baseball still has a mass of 0.2, but now it has a velocity of 40. So we have a momentum of 8 sphere. Now, going back to our impulse formulas, right? M delta V, or M final velocity minus initial velocity, or you could use change in momentum. So you could use final momentum minus initial momentum. But did anybody catch the trick? What type of quantity is velocity? That's right. It's a vector quantity, which means momentum is also a vector quantity. So this ball going in this direction has 12 spheres of momentum, right? So this guy, 12 spheres of momentum because he's going in this direction. This baseball is going in the opposite direction. So we have to make this amount of momentum a negative, right? Because it's in the opposite direction. Because this velocity up here is a negative. So if I'm going to use this formula, I'm going to use the impulse imparted is going to be 0.2 times a negative 40 meters per second minus an initial 60 meters per second. So 0.2 times 100 is going to be a change of 20 spheres. So the impulse imparted is 20 kilogram meters per second, not 4, not just 12 minus 8 for a change of 4, but negative 8 minus 12 for a change of 20. Technically, I guess I ought to make that a negative, right? Okay, let's make that a negative. All right, let's take a look at the paper, the worksheet that came along with today. Okay, so here's the worksheet that came along with today's lesson. Let me see if I can get this off the screen here for you. There we go. Let's take a look at what we have. This chart going on up at top. So this chart has force and time. What do we know if we multiply force by time? That's right. That's equal to impulse. But impulse can also be talked about as a change in momentum, which is also equal to a mass times change in velocity. So the way this whole chart works is you're given something in here where you can figure out one piece of this which makes it all the same. So here I've got a mass of 10 with a change in velocity of negative 4. So I'm multiplying those two together. That's going to give me a change in momentum of negative 40 kilogram meters per second. That impulse, Newton seconds, is also negative 40. And if that time interval that it took to create that change was 0.01 seconds by dividing 40 by 0.01, that means I need a force of negative 4,000 newtons to produce that impulse. So all of these things are the same thing. Force times time, impulse. Impulse is the change in momentum. The change in momentum is the mass times the change in velocity. So you can fill out the remainder of this chart. There's also a couple other questions down here. Define impulse and momentum. Should be easy to do now. Which block has a greater momentum? And which has a greater momentum? Answer those. Okay, so let's finish up these questions. Don't forget to submit this assignment when you're done. I'm glad that most of you are keeping up with the daily word of the day, problem of the day that's posted every day in Google Classroom, as well as the other work that's been being posted. That's great. Let's keep up the good work. Your grade this marking period is all dependent upon those assignments. So you need to keep working on those every day. If you have questions, you can always email me. Also, Gear Up will be providing tutoring if you need it. That could be in any of your classes through Dr. Benji or the other Gear Up tutors. So if you're interested in a tutoring session with Dr. Benji, let me know. I can get you in touch with Dr. Benji so you can set up a time where you can do some tutoring as well. Okay. So the big thing is let's stay safe. Let's keep working hard. Let's get through the remainder of this year.